Number 8, object. We're given I and j values for its initial position. We're given I and j values for its initial velocity. And we're given constant acceleration. We're given a time. And after 4 seconds, it's at that position. So we're given a final position. Determine the acceleration of the object. Give your answer in component form. When you're studying for the test, you should look at all the topics that we covered. And one of the topics we covered in this module was two-dimensional acceleration. One of the key points of that was if you have constant acceleration, you can work it as two independent one-dimensional problems. Solve for x, solve for y, and then find the answer. Alright, so let's do that. X and y. Okay, we do not know the acceleration. That's what we want to find, determine the acceleration of the object. But we do know initial and final position. We know delta time, and we know the initial velocity. We do not know the final velocity. So we're looking for the equation that does not have final velocity in it. And that equation was our initial condition equation. I'll just go ahead and write it up here once. x2 is x1 plus vx1 plus vxt plus 1/2 acceleration in x t squared. Okay, we know everything except ax. We'll have a similar equation for y. We'll know everything except for ay. When we can solve for those two, we can then put them as a vector component form and have our final answer. Alright, so our final x, right here, 12. Our initial x, 4. Our initial velocity, 3. The time was 4 seconds. And 4 squared. So again, I'm going to use the solver here. Pretty simple algebra, but this will let me type everything in and also practice using the solver. Alright, so I'm still in the solver. I'll just let's see, quit out of it, get back into it, math 0, go up arrow clear. Alright, minus 12, moving that to the other side, plus 4, plus 3 times 4, plus 0.5 times x, my variable, times 4 squared. 12 minus negative 12 plus 4 plus 3 times 4, double checked, looks good. Looks like alpha integer, give me a value of minus 0.5. A little bit of round off here because the solver is approximating, so don't write down a bunch of decimal places. It's pretty obvious that that should be the right answer to minus 0.5, and we're working in feet and with our acceleration, so that's going to be feet per second squared. Alright, I'm going to do the same thing with y. Okay, my final y is 6. It's equal to initial y minus 10, don't forget the minus sign in there, plus initial velocity minus 7 times 4 plus acceleration in y times 4 squared. Okay, again I'll use the solver. Minus 6 minus 10 plus minus 7 times 4 plus 0.5 times, I'll just use x for my unknown variable again, times 4 squared. alpha, enter. 5.5. So A sub y is equal to 5.5 feet per second squared. Okay, I'm double checking my numbers, and let me come back here and just erase some of the scribbling I made to see that that was actually a positive in there, and I read it as a negative. So I'm going to come back and fix that in my equation. Here's another nice thing about using a solver is if you still got the equation in here, I just up arrow and change that number, or change that value. In this case, just delete it, and I don't have to retype in everything else. Alpha enter minus 1.5. Okay, I'll buy that. And so I shall fix that right here. Ah, come on. So my final answer in component form is going to be minus 0.5i, that's the x value, minus 1.5j, that's the y value, in units of feet per second squared. Alright, I'm done working the test, but I'm going to take a second here. Not to check all my calculations, it'd be nice if you had time to do that, but at least to check to make sure I've got correct answer, valid answers for all the problems. So I'm going to check to see what each one's asking for, make sure I have units, and make sure everything is 3 sig figs or less. Alright, determine acceleration. I've got feet per second squared, that's acceleration. I've got a component form, so that one looks good. Going back here, I had graphs. It said label all my points. So I've done that here and here, here and here, and I filled in the graph. I've shown my calculations. Okay. Let's see, we're looking for an initial velocity, keyword velocity, so that is going to be a direction. Okay, I've sort of done that with a minus sign, and I've got a units of velocity meters per second. Okay, the plus 48 and the plus final velocity here give the connotation that this is a one-dimensional problem, and plus or minus will give our direction. Okay. Let's see, total distance object traveled. So I'm going to use feet here, and doesn't matter for direction. Work that one okay. Magnitude of the sum of the two vectors. So I just need a magnitude. The vectors were in feet, so I should be okay there. Looks like I have a reasonable answer. How far and in what direction? So we're in units of meters, and I give a direction, I've given a reference. So everything looks right there. Measure the angle counterclockwise from the positive x-axis, express the vector. So I have a vector, 29.7, and 312 degrees is our angle, and we have units of feet. Came from right there. And lastly, the cubic dualies. So dualies cubed, units conversion. So it didn't take me just a couple minutes, and I've double checked and should not lose any points on units or sig figs.